Happy Tuesday. So catching up from last Friday, from yesterday, Monday, we've got compound interest. Now, we've spent some time, we've solved for F, solved for P, solved for R, solved for T. We cannot solve for N because N shows up two different instances, and that's a mess of math since one's in the exponent and one is inside the parentheses. That's not very likely to be happening. So we've got compound interest. We can solve for all the different pieces. Today we look at two different applications of compound interest. And this is where we talk about economics, the way banks work, and things, common terminology that you'll see out in everyday experience. First off, we have what's known as annual percentage yield. Now, APY, there's two different things that you'll see in the banks. You'll occasionally see APY, which represents annual percentage yield. The other item you'll see is APR, annual percentage rate. Now, the annual percentage rate is what banks typically tell you that's a R, annual percentage rate. That stands for, they say you've got a 5% annual percentage rate on your account. It does not take into account the number of compounds. Annual percentage yield is the entire percentage of change. So usually APY is a little bit higher than APR, and it's just a way of recognizing the percentage of change before or after the number of compounds are considered. Credit cards usually list you as APR. They don't tell you about that they compound things on a daily basis, and therefore the annual percentage yield, the actual percentage per day, is a little bit higher than otherwise. Banks try to tell you usually annual percentage yield, in that number is higher than the APR, so that it makes it look like they're paying out more interest. It's a way of just manipulating the numbers. So the way we can figure this out, it's the actual amount of change on a yearly basis. So we should recognize that from our compound interest. T, we're going to say on an annual basis, so T is going to be 1. So this would then be multiplied by the P in the formula, getting us the final amount, or whatever that is. This is the percentage of change. We subtract 1, taking away the 100%, so that we get the actual, just a percentage increase on a yearly basis. How we can figure this out, or how we can interpret from the banks. We've got an annual percentage rate of 8%. What would be the APY, the annual percentage yield, if we compounded quarterly? Example 6, this goes into the notes from Friday, from yesterday, from Monday. It's example 6 out there. We want to find the APY when we have an 8% interest rate compounded quarterly. So our APY in this account, plug in the numbers, 1 plus 0.08 over 4 raised to the 4th power, subtract 1, go into the calculator. We've got, in parentheses, 1 plus 0.08 over 4 raised to the 4, subtract 1. That tells us 0.082, meaning it's an 8.2 percentage of change. So if you have $1,000 in the bank at an 8% interest rate, if it's compounded quarterly, you would get 8.2% at the end of 1 year, not just 8%. So if we had $1,000, 8% is $80. You'd have 8%, you'd think, okay, $1,080. Well, in fact, $1,082. You get a little bit more because it's compounded more often. This would be compounded once per year. This is what we actually get compounded quarterly. Let's do another one. What would happen if this was compounded daily? Let's do monthly instead. I think that's what it is on the notes. So instead, we're going to do monthly. So APY, if our account is calculated monthly, 1 plus 0.08 over 12. Now what that's going to do is that percentage becomes smaller because we're dividing it by 12 pieces. But then we raise it to a larger exponent. Our APY on a monthly rate, into the calc, 1 plus 0.08 over 12 raised to the 12 is 1. We get 0.0829, giving us 0.083, 8.3% APY, slightly better. So banks usually tell you the APY because it makes it look like they've got a higher interest rate. Credit cards, on the other hand, usually tell you the APR because then it makes it look like they have a lower interest rate. It's going to do the same thing for you. It's just that financial literacy Go out, check out your bank, see what they say. Check out your credit card statement, see what that says. Look for APR versus APY. Next application of compound interest is inflation. Inflation is the idea that over time, money decreases in value or the cost of goods goes up. As an example, when I started teaching my very first job, I made about $40,000 a year. That was being 6 years of school, 2 bachelor's degrees, and master's degrees. I was feeling pretty good about myself. My mother started teaching about 35 years before that. So when I was making $40,000 a year, she made in her first job about $6,000 a year. Does that mean that I did such a better job than her? Probably not. Namely because I know how I work, and I know how she works, so definitely I'd say she did a lot more work than I did. But it's a little bit of a combination of $6,000 in the mid-70s compared to $40,000 in the mid-2000s. What's the purchasing power? Well, you think about your own college costs right now. You've got your own college costs right now. You talk to your parents. Colleges used to be $4,000 or $5,000 per semester, and now you're looking UConn in-state school, $25,000. You are not getting 5 times the education. It's the cost is increasing, the value of money is decreasing. So we can think about inflation in that sense. Let's go through some examples. Now, inflation is an annual compounding rate. So when it says rate of inflation is 4%, that's going to say our R value is 4%. If we've got a current cost of a current item, that gives us our principal. Cost, so if we're talking about the cost, and once again, this is example number 7 off the notes, we say the cost of a car today is $23,000. If we waited 5 years, how much would we expect the same kind of car to cost? We'd use P, 23,000 as our current amount. We'd be looking for the final amount after that given period of time. Now, N, whenever we talk about inflation, is going to be 1. It's an annual rate of change. That's where like the APY comes into play. It's the annual rate of change, the annual yield. Compound interest, we know this, F equals P, 1 plus R raised to the T. I'm eliminating the N because N is 1. So anytime we talk inflation, N is going to be 1. We can find out car today, $23,000, your Honda Civic or whatever. How much would we expect it to cost in 5 years? Plug everything into the formula. It's a straightforward calculation. Car valued at $23,000 today. We'd expect it to cost almost $28,000 in 5 years. Not that you're getting a better car, it just costs more. On the other side, so we can find P, we can find R, we can find T. We can also find, last one we found F, we can find P. So here, 2011, let's say you're making $40,000. You're out of school, making 40 grand in your first year, 2011. Well, if you go back 21 years, say when your parents were out of school, are they better off than you or worse off than you? Do you have it easy because you're making 40 grand, or did they have it easier when they were making 20 grand? So here, the average U.S. inflation rate from 1990 to 2011, this is example 8 off the notes, it's about 2.5% per year. So there's our R value, 0.025. I'm saying find the salary in 1990, work backwards, solve for P, equivalent to a $40,000 salary in 2011. That's a time span of 21 years. So our compound interest, we've got 40,000 now. Solving for P, do this and divide. So a $40,000 salary in the year 2011 would be equivalent to making only $23,000, almost $24,000 in the year 1990. Quite a bit of a difference, or saying that the amount of purchasing power that you had with this is equivalent, or you would need to make $40,000 today just to get by at the rate that you would have made $23,000. That's rough. All right. That's Tuesday. Tomorrow is Wednesday. It is a half day, but there's going to be a quiz. Simple interest, compound interest. Know the formulas. Make certain you bring your calculator. Have a good day.